Welcome to Library Seminars, a NOAA Central Library educational platform for the presentation of research and ideas in support of the National Oceanic and Atmospheric Administration's mission. Today's presentation, Semantics and Machine Reasoning Enable Fair, Web-Based Data and Model Integration for Ocean Accounting, is sponsored by NOAA's Performance, Risk, and Social Science Office, PRSSO. Dr. Monica Grasso, Chief Economist from PRSSO, will introduce today's three speakers. Before I hand over the mic, here are a few logistical items to help you enjoy this webinar. If you have trouble with the audio or visual components of GoToWebinar, we suggest that you log out and rejoin us. This usually resets the software and resolves most technical issues. Our presentation is being recorded and will be available on the NOAA Central Library YouTube channel later today. I've added the link to the chat box for your convenience. Audience members are muted. However, questions are encouraged, so please feel free to type them in the questions chat box located in the control panel as they come to you. All questions will be answered after the speakers conclude their presentation. So with that last detail, let's get started. Monica, the microphone is yours.
Thank you, Lisa. So as Lisa mentioned, today's presentation features a pioneering artificial intelligence application for rapid natural capital accounting. And this is a project of the UN Department of Economic and Social Affairs and the UN Environment Program, also in collaboration with the Artificial Intelligence for Environment and Sustainability Platform, or ARIES, at the Basque Center for Climate Change. This seminar will describe how ARIES modeling platform uses AR based on the FAIR principles for scientific data, which means that to maximize its value, scientific data should be findable, accessible, interoperable, and reusable. By applying these principles, ARIES allows users anywhere in the world to find information that can produce rapid, standardized, scalable, and customized ecosystem accounts. The approach has been applied to natural capital accounting in partnership with the UN and could be naturally extended to ocean accounting. So our office and NOAA is exploring the possibility of using ARIES to inform some of the next steps in the work we have done with the Bureau of Economic Analysis to produce a marine economy satellite account for the US. And this account features statistics on business for 10 sectors of the economy that depends on the marine resources. So now I would like to introduce our speakers. Our first speaker is Ken Bagstad. He's a research economist of the US Geological Survey, working to account for nature's value in decision-making by US federal government agency and others. And he's also co-leading the development of natural capital accounts for the US. He holds a PhD in ecological economics from the University of Vermont, and from 2015 to 2016, he was a senior environmental specialist with the World Bank's Wealth Accounting and Valuation of Ecosystem Services, the WAVES program. And since 2010, he has partnered with various US government resource management agencies on ecosystem services assessments across the US. We also have Ferdinando Villa. He is a professor at the Basque Center for Climate Change. He started out as a theoretical ecologist and had a long parallel career as a scientific software engineer, designer and engineer. After carrying out research in many fields of ecology, he worked for 15 years in ecological economics at the University of Maryland and Vermont. He has authored and co-authored 150 plus scientific publications and has received major research grants from the US National Science Foundation, the European Union, the UK Natural Environment Research Council, UNEP, and other institutions. And Stefano Balbi is also a research fellow at the Basque Center for Climate Change. And since completing his master's in environmental economics, he has studied natural capital, human natural systems interactions from a holistic perspective, where theories and approaches from both social and environmental scientific practice are integrated to better represent behaviors, spatial dependencies, and temporal dynamics. This led him to pursue a PhD in analysis and governance of sustainable development, and to direct this interest towards research in human geography to explore the complexity of socio-ecological systems. So before I pass to Ken, I just finally want to say a big thank you to our amazing speakers today for being willing to talk with us about their work, and also to the NOAA Library, and especially to Lisa Clark for helping us with the logistics of the seminar. So now I'll pass to you, Ken.
Thanks so much, Monica. I'm going to give about a 15-minute overview presentation and then hand it off to Ferdinando for a demo. So to get started, we are going to be talking today about environmental accounting, and specifically potential applications to ocean accounting. A lot of this work sits within the System of Environmental Economic Accounting, or the SEEA. For those of you who aren't familiar with it, this is an international system. It's been developed by the UN with support from statistical agencies of national governments from around the world. And ecosystem accounting itself was just very recently approved as a statistical standard earlier this year. There's been a lot of interest naturally in extending this work to ocean systems, where it's a little bit newer, and the Global Ocean Accounts Partnership is one organization that's working to do that. That's working to take some of these concepts and apply them towards oceans. In essence, the last thing I'll say about this is that environmental economic accounts are designed to track the extent, condition of ecosystems, as well as the services they provide to people and the economy, and to do so in physical and monetary terms in ways that link to our national economic accounts. So that's really the goal and the overview of SEEA. A lot of the work that we do in ARIES is about making data and model assembly faster by cutting out a lot of the manual data processing and making data interoperable and reusable. So if we look at our standard data flow, we're used to spending a lot of time and money on science, especially for mapping and GIS-based work, spending a lot of time collecting and organizing and cleaning GIS data. Scientists go through past studies and figure out where new data needs to be developed and where old data can be reincorporated. And at the end of the day, hopefully the data goes in the repository where it can be used in the future. There's an assumption here that's built in that you can't do good work quickly, because it takes really painstaking time and expertise to get the kind of answers that are scientifically rigorous. We believe that with some of the technology we've been working on, this doesn't hold true, and that we can actually get science done much quicker, especially for people who need answers at the speed of decisions. And one way we can do this is by having experts contributing their data and models on something called the Semantic Web, which is a way of storing your data, models, and scientific knowledge in a way that a computer can understand, recognize, and reuse them and assemble them for a user. So when a user has a query, they type it in and they can get results quickly. And we'll see a demo of that coming from Ferdinando a little bit later. So who might this person be on the left who wants a quick answer? You know, we could think about local NGOs that might want results. We could think about state agencies, for instance, or ocean-oriented businesses. These are all groups that typically don't get the natural capital information they need because it's too time consuming and complex to achieve. And there's a lot of cases where this information could filter out to people making decisions more efficiently using systems like ARIES. So Monica mentioned FAIR. FAIR, as we said, is findable, accessible, interoperable, and reusable. It's really a standard for modern open science. And a key piece of this is that data needs to be findable, accessible, interoperable, and reusable, not just to people, but also to computers. And interestingly, Data One, which is a federation of about 40 data repositories, did a study about a year ago looking at how fair their data are. And what they found was that their data scored fairly well for being findable and accessible. And this isn't a surprise. You put data up on the web and provide ways to organize it. You can find it through search and you can access it. What you often can't do well is have it be interoperable, which is able to be recombined and used together in a very streamlined way, and reusability. And we see the interoperability and reusability metrics lagging, and things have not gotten better over time. So the status quo is not helping there. Now, what ARIES tries to do is, to solve this problem, is we take artificial intelligence, and if you've heard of AI, you've most likely heard of machine learning and deep learning. Those are the really popular and commonly used techniques these days, but that is not all of the AI world. There are other tools out there, notably semantics and machine reasoning that we use, and I'll describe those in a minute. So we use some other AI technologies that are critical and underpin ARIES. Semantics are, at their simplest, they're a way of labeling data and model elements, things that we might take scientific observations of in a way that's consistent and logical. And so a machine can recognize things. If you're a scientist who has two people writing metadata for the same piece of science, they'll never be the same because people always describe things differently. And a human who's looking at those two different data descriptions might be able to realize that they're the same thing, that they're comparable, but a computer almost never will be able to. So common semantics are really needed in this case. What ARIES does is it uses machine reasoning and algorithms for reasoning. And what reasoning, a very brief description of reasoning is making decisions based on information. And humans do this constantly, almost without thinking. We do this so many times a day. For instance, in looking at a weather forecast, we decide what we should wear. If it's cold, we wear long sleeves or a coat. If it's short, you'd wear a short sleeve shirt, for instance. So what we choose to put on depends on what the weather is. We get information and we make a decision. We want to equip computers to do the same thing, to be able to make a decision about what appropriate data and models could be for a particular application based on the part of the world, their spatiotemporal scale, or other factors. So once we have computers that have the algorithms to be able to make these choices based on information, and we have rules about when and where to apply certain data models and model parameters, plus semantics that describe the data clearly and unambiguously, along with an ecosystem of open data and models and open source software, we're able to get fast and fair multidisciplinary modeling. I'm not going to spend much time on this slide, but it's a question we always get, which is how does a computer pick the best available data and models? And this is an example of some of the criteria that our reasoning algorithm can use to pick what the most appropriate data or models would be under which circumstances. Things like the scale, things like getting as local or as high quality a data as you can for an area of interest. And we can talk more about this, but again, it's a question that always comes up and is the criteria that a computer uses to pick data and models. ARIES includes the open source software as a key piece of this, of course, and we have interfaces for both non-technical and technical users. On the non-technical side, the goal here is to provide through a web browser a way to access and run scientific models in minutes using cloud-based data and models, and to do so anywhere on Earth. Ferdinando will give a demonstration of that. And then on the right side here, we have an example of the technical users interface, which is an integrated development environment that's designed for users to contribute and add their own data and models, to test them, and eventually to be able to share these with the scientific community so that they are accessible through this web browser interface on the left. We mentioned, or in the introduction, the idea of ARIES for SIA was mentioned, which is our collaboration with the UN on building a rapid tool for environmental economic accounting. And what we can do with ARIES is we can provide models that will run anywhere on Earth on global data, and yet at the same time, they're rapidly customizable using the best available local data and knowledge, including model parameterizations, for instance. So now, unlike the past where ecosystem accounts, which require a lot of spatial modeling, were very difficult and time consuming and could only be done by experts, and this really limited their use in the global south. Through the ARIES for SIA interface, which Ferdinando will demonstrate, which was released just back in April, these accounts can be compiled anywhere, and they can also be improved with local data where that's available. The maps and the tables get produced automatically, and most importantly, we're providing the infrastructure for the community to share other data and models to make them interoperable so the system can grow and improve with time. Some examples, Ferdinando will give, I'll give this more in depth, but looking at some potential ocean applications. We could look at, for instance, the condition of oceans related to sea surface temperature or chlorophyll concentration. You can look at how these change over time and how they differ across space. So here's an example, of course, for part of the US Atlantic coast. These are interesting, there's interesting coastal applications too, and we could look at, for instance, how ecosystems are changing in the coastal zone. This is an example for Miami-Dade County, Florida, using the ecosystem extent accounts for this part of the coastal US, which is changing quickly. Here's a map of ecosystems for the year 1992. Here it is for 2018, so we can see the urban expansion of the Miami area in red there. And the tables get built automatically, as I mentioned. So this is these are tables showing the change over those years. I talked about data interoperability. We really want to share, especially for the scientists who might be on the call, this vision that we'd like to be able to recompile these accounts quickly as new science emerges using the best available science. We want to be able to quickly produce recent time trends. So when new data become available for, say, 2020, we want to incorporate those as quickly as possible to produce accounts that are accurate and timely. And we'd like to be able to do good international comparisons, and at the same time also be able to do customizations wherever possible. So this vision gets information that's as high a quality as possible into the hands of decision makers as quickly as possible. And that's really a part of the vision that we're trying to grow with this increased emphasis on interoperability. We have a document that specifically describes this related to SIA, and I'll just say again, this is a little more targeted to scientists, but how do we take existing open data practices and build on them so that we can get to interoperability more quickly and a growing library of data and models that can speak to each other through ARIES. So this is available for the more technically minded in the audience. And the question of how we get there, we of course have open link data and models. Well, we have open data and models through software and code repositories and data repositories. But a few basic best practices. I won't spend a lot of time on the slide, but just to say that we need to go beyond the current state of the practice. Not only do we need to put our data and models online, but we need to have a shared and common semantics that describe them so that a computer knows what it's looking at. A computer can combine these data and models, and rather than just saying we're going to put it online and that's going to be the end of the story, we need to make sure that they're in machine accessible and machine readable formats. So these are some of the considerations for actually getting data and models to be interoperable. This is my last slide here. I just want to talk about what ARIES for SEA oceans could look like. Who can help make this vision a reality? And a lot of the natural capital accounts, including for the oceans, are being led by national governments. So there's a real benefit here in that you can get a quick start on ocean accounts. If we have the data and models available, there's the potential to compile the accounts both the first time and in the future using a very streamlined flow of data and models and processes. Also ensuring that they're reproducible and transparent in future compilations. So that I think is very important. What needs to go on the web in a semantic fashion in order to make this happen? We need the global and national databases on ecosystem extent, condition, and services. And so here are some of the considerations for making that a reality. Today, there are countries around the world that are developing ocean accounts. It often takes months to years to develop these, and recompilation of accounts isn't guaranteed. That can take a lot of time too. What we envision is that with ARIES for SEA extended to the oceans, this would be could be accomplished in days to weeks rather than months to years, following a fairly minimal training. So it doesn't take much to get up to speed once the data and models are available, and then the accounts can be compiled pretty quickly. But what it does take is an initial investment in data model management, and this is what this is the work that the UN funded with our initial ARIES for SEA, which was focused on terrestrial ecosystems. But we'd like to do the same in the oceans, and we're of course interested in partners who would like to help make that a reality. So I'm going to end the formal presentation there, and I'd like to hand it over to Ferdinando. This is a bit of contact information about the project if you'd like to get in touch either by web, email, or social media. And with that, I'd like to end this part and hand it off to Ferdinando for a demonstration.
Thank you, Ken. I will turn on all of my complexities here, so people can see my screen, but I'm not sure which screen. Give me a second to check that it's the right one. It should be. Okay, it's good to see everyone, and thank you for the invitation. What I'm going to show, I hope nobody feels duped because the ocean accounts is in the title of this webinar, but we are really, as Ken already said, we don't have any ocean accounting models or methodologies in ARIES at the moment. So what I'm going to show is just a couple of ways to access ARIES. And I'll start with the ocean because the simplest way is to just ask for things, just explore the system. We're using this interface that we call the Explorer. And after I've shown you some marine stuff, I will immediately move back to the secure ground, to the secure land that we are much more familiar with, and show you some examples of accounting that we can do both from just a simple modeling perspective and from a perspective of using the application ARIES for SEA. So I apologize, 1 second, I need to ensure that I don't have anything blocked here. Sorry about this. And I'm going back to my presentation. Okay, so the way to use the system, as Ken said, the system is a semantic platform, and by semantic we mean that it does try to understand what you ask to it. So the simplest way to use it is to connect to an explorer, and you can find one online. I'm connected to my own machine at this point, but I will show some examples of online usage later, and it's completely identical to using it like from your own machine. You have those options yourself, and just ask for things. And because we want to talk about the oceans as much as we can ask for some oceanic concepts, like, for example, exclusive economic zones. Sorry, I'm bad at typing. I don't know why it's taking this long. Search timeout. I'm sorry, I think I will have to Oh, it's terrible. I am. It never happens except when I'm presenting. So I think I will switch to the other application. I wanted to show you selecting some of the exclusive economic zones in this area of sea, and then making some observations in there. But the system is not helping me, and I need data that are on this machine. So I will just switch to something else and show you the same things, but I will have to go through the land accounts, because I don't have on the public release, I don't have any of those. I apologize about this. So I will connect to this engine, which you can do yourself if you want. This is the hosted on the UN Global Platform, so it's our public instance to give access to different applications. And when you log in, you can get an application like this, or you can log in a simpler way, like doing, for example, like this without this part of the URL. And you can be asked if you want to use a specific kind of application, or choose among the set of applications that are available. So when I log in on this other window, I get a choice, while on this application I had the URL of the application for the CR directly. So I will start with the Explorer, which is the simplest application possible. And in the Explorer, what you do is simply to ask for some observations to make. And the way you do it is to, for example, move to an area of interest, like here, for example, in Africa. You can go all over the world, and then start typing what you are interested in. If you start typing, the system doesn't match your string to a keyword, to a set of keywords, but it does match them to concepts. And that's a big difference. So the machine knows what elevation means and is able to understand from your question whether your question can be addressed directly by just looking for some data, like in this case. I just pressed return here. Or there are ways that the machine needs to look for much more complicated instances. There, I chose a pretty flat area, so it doesn't look like much. Today is not my day, but you can go somewhere else, like in other parts of Africa, for example, and you will see things that will look very differently. Now, the question that I made before, just asking for elevation, which I can repeat here just for the sake of it, in this context, is addressed very simply by picking a data set from the network and just finding the match between the data set itself and the resolution and the specific boundaries that you have in this observation window. And obviously, you can choose, the machine will choose some defaults for you, but you can also choose your own resolution, your time, etc. So by simply inputting the resolution you want in space, for example, or your period of interest in time, you can choose a particular year, you can choose a particular time step, etc., etc. The machine will adapt the response to the context of interest. Now, if we move, like, for example, here, and we ask for something that's much more complex, the machine will not respond with just a piece of data, but it will respond with potentially building a much more complex model. And we do have, for the user, so if I press the space bar here, the machine is, I'm connected through my account, so the machine knows what I'm interested in, because I have made queries before, and also because I'm part of groups that you can opt in or out, that basically tell the machine which kind of topics are you most likely to be interested in, so that we can provide you with something which is a little less scary than a blank canvas. So we can give you some predefined questions. And all these questions are actually concepts. So they are not models. They don't select a model, but they select a concept that you can observe in this context. The story is that once you have selected a concept and you press return, the machine will find the most fitting way to observe this concept by building the best model, including the best data and the best methodologies that fit your context of interest. And by that, I mean not only the region you are in, but also the time you are in, the resolution you are in. So you could build models at a small scale that actually include urban interactions, for example, that would be ignored if you are at a regional scale, for example. So let's choose one of these so I can show you how the machine starts this reasoning process, and press return. The machine gets to work, and this work results, first of all, into building a model structure, which you can visualize from here. So what you look at here is not a model that anybody of us has actually built as an entire monolithic structure, but it's a model that the machine has built based on existing components. So it realized that in order to know the net value of pollination, it has to put together the length over type, and that can be used to understand the yield to yield ratio in pollination, occurrence of insects, etc., etc. And you can see the model being computed as this graph moves around, and as things are computed, you can see data coming in, like length over type in here. You can click on the various categories in order to know what's going on. And basically, the algorithm is flowing through this flow chart. And when you see a box that has become dark gray, it means that it has been computed. You can also click on the different boxes here and get information about the algorithms that have been computed. So at some point, very quickly, the machine will have finished. Actually, it already finished. It should just stop the yellow spinner here and give us the final results that are here. So you see a net value of pollination map that gives us a value which is between -1 and 1, roughly. If it's 0, it means that there is a balance between the demand for pollinators and the request coming from pollinated crops. And if it's red, it means that there is a deficit of that, so there are more crops than in need of pollinators than there are pollinators available. And if it's green, it could mean in this particular case that there are no crops, but there are pollinators, or there are more pollinators than any crops need. And you can investigate and just explore this kind of interface as much as you want. Now the machine is actually computing a temporal as well, a temporal context, because we asked for the time for several years, so you can see this bar moving. So it will give us the entire evolution of this environment, starting from the beginning of time that we chose, and it could have been chosen by modifying the options over here, and ending into the final time. So basically, the interesting part about this Explorer, as we call it, it is very flexible. You can just ask a question. You don't have to choose one of the questions that you find here. You can actually make up your own question, but so there is a lot of questions here that you can be interested in exploring. This is mostly for ecosystem services and natural capital accounting, but according to who you are and according to the group and according to what is the context, the content of the network at the moment, you may find many others, or you could build up your own question by just typing. And in some situations, you will get a no sorry response telling you that there is no way to measure your concept with the current knowledge. But as the system gets more used and as people, contributors of all kinds, participate in more projects and put more data and more model components on the network, more and more questions become available, and the machine learns to solve more and more complicated problems. And as you saw here, all I did here was just to choose one concept. So you can see this interoperability paradigm working at the user level. So the user puts up a concept and machine builds a model. This is just a one-off activity, which is already quite attractive because you can do quite a bit with that without having to set up any particular simulation, worry about resolution, data preparation, model component choosing, etc., etc. But obviously, a model can do the same. So our models, when we build those models, they don't have to tell the machine how to compute each of the inputs they need, because they just have to mention the concept. So just the way the user just mentions a concept, a model also does the same. So you can see that the models, like in this case, make it a little larger here. This is the pollination model that you're looking at. And as you can see, the entire thing is like 50 lines, because each part of this model is simply mentioning the concepts and then defining the operation you want to do when those concepts have been observed. You don't have to tell which data to link in, which models to use. Each concept can be observed independently. So in the interest of time, I will switch to the ARIES for SIA application, which is taking my same context that I had that I've taken before. Maybe I will want to reconnect and change my session, so I can just do the same in a different place, just to not show too many strange things. So that we are reloading the application. It gives us the same context that we were in before, but now we should be free from the context being computed before. And we can choose our context. And now the choice, because we have an application here, what happens is that the Explorer is still behind all of this, but we can use the Explorer as an application development environment, so we can build this kind of facade over the Explorer, so to make the life of modelers and decision makers that are interested in a specific kind of modeling much easier, without having to actually ask for a specific question. We just pick things from a menu. So what we can do here is, first of all, we don't have to use rectangular boundaries. We can use an administrative region, for example. And if I switch to this, the machine will show me the regions available in this particular region, and it should give me the boundaries of the regions, or they can give me boundaries of river basin. I don't see that happening at the moment. I don't know why. It's probably because I'm presenting it. Normally it works perfectly well, but I'll just give you this very general overview. And once you've done a selection for your context, and this obviously could contain and include marine boundaries, exclusive economic zones, any kind of other type of observation that you may want to observe in the marine context, you can pick the kind of observations you want to make. Now, we're talking about accounting here because the application is specifically for natural capital accounting. So the final result of all observations here are not just maps or other things, but they are accounts, which means that basically you get tables of organized results that are compliant with the UN endorsed SIA standard. So if I click on this, I should see this working. I'm very sorry. Things are doing. It's really the first time I demonstrate, and the system is not responding. There must be one of those days. So one thing that I will do is to reconnect to my own machine, but it will take a minute. So I don't know why today has been so difficult, but we have a lot of demonstrations on the web as well. So maybe if I run out of time today without being able to show you what I want to show you, maybe we can switch to another kind of demonstration. In the meantime, I'll try to go back to this. Maybe I'll be able to show you something from here. Let me check.
While you're working on that, Ferdinando, we do have some questions. I can go ahead and read
please.
some questions.
Maybe Stefano and Ken want to take them while I work on this.
Excellent.
A very strange situation.
No problem. So this first question asks, in terms of data and semantic harmonization, what are the leading taxonomies or standards we should consider to be in concordance with SIA, I should say? Yeah.
We have, so SIA is a standard itself. So it's actually, what happened this year is that it was approved 1 month before we launched the application. And all the models that we have implemented in the applications, in this application, are in line with the standard that was actually vetted by the community working on the SIA standard. So that is one part of the story. The other part of the story is the use of semantics in general for modeling. And obviously, there are already a lot of resources out there, dictionaries, thesauries, and in general authorities. Like, for example, for species, you have GBIF. For chemistry, you have UPAC. So we try to reuse all the work done by these authorities. And so everything that has to do with chemistry and species, for example, we don't invent anything there. We just take the work that has been done already in the past. So these are the two sides of the answer.
Yeah, there's quite a bit to say about, I mean, adopting a particular semantics, but we try to make it as simple as possible for the majority of non-technical users. So the semantics actually come as a template. If you run a model like this, I was fortunately able to reconnect. You get the semantics already from here. So if you want to add your own data for this, for example, we are building ways to upload the data that already are tagged with the semantics that you are using. There's this upload button, for example. So in most situations, you can use an existing model, or you can use an existing structure as a template, so you don't have to worry about finding the proper semantics. But if you are typing your own concept, then at that point, you have to use a kind of a search engine, and the machine will assist you by not letting you add a concept that doesn't make sense along with the previous one that you already typed. Obviously, there is a blank canvas effect there, so it can be quite difficult. Our work in semantics is inspired by the most modern ontologies being built by NASA, by others, and the vocabularies that Stefano was mentioning. But we're trying to simplify that, and we're trying to take a different approach that uses the structure of the English language in order to make it a lot easier for users to identify the proper semantics. But the reason why we have applications like the one that you're looking at is that in these applications, you don't need to know anything about the semantics. You make a choice, and then the semantics comes out as an output, not as an input. And then at that point, you can use the semantics in order to actually provide your own data that use that same semantic using an existing model as a template. So there are quite a bit of ways to approach this problem. And as you may have seen here, I was computing an extent account for Normandy. I was there, so I just clicked the button and hoped it worked, because I had this bad experience before. So if you click on this, you get your maps as before, and you can get the temporal evolution of these maps, like in this situation. But the real output from the point of view of accounting is the table, and you can get the table from here. And this is the SIA compatible table of ecosystem types and area at the beginning and at the end of the period of interest that is endorsed by the SIA standard. And you can easily transpose this example into whatever other kind of accounting and into any kind of environment. So it can easily be a marine account or any other kind of account. There is no preclusion. The system is, for the system, knowledge is data. So the system doesn't have models wired into the software. Whatever concept you add to the ontologies, as long as you put data and models that respond to those concepts, those can be computed. So the infrastructure is completely general, and we are very eager to move into the marine environment. Now, let me show you, before my time is over, let me show you what the machine produces in addition to data, as you see here, and in addition to models that you can see over here, and you can look at the models and from a technical perspective, understanding everything that those models have done. We have a very extensive reporting view that gives you different perspectives on the results. So this is the perspective for the accountant, and we can actually put some other accounts, some that compute relatively quickly, like carbon regulation or sediment regulation. You can put as many as you want. The system will compute one at a time and put them in a queue until it's done. This is the perspective just for the tables, which you can export as Excel, copy to Word or to any other structured editor. But there are more tabs here, and the most interesting one is this one, which gives you a structured report, which you can just print. And this report basically gives you everything there is to know about the computation that has been done, including a complete documentation of every aspect of the models that you've been using. So, as we said, the model is not written as a monolith into the system. The model is assembled by the machine, but each component and each data set has its own documentation, so that the machine is able to just recurse all the structure and build the model. And as you can see, it's changing as I speak, because I'm also computing carbon models, and everything that I'm computing in this same context is being added as we speak to the report, including links, methodologies, tables, figures, tables that the final results, and we have properly referenced. You see that it's coming, it's happening as we speak. We have cross-referenced citations, etc. You can print this and publish this. It's not impossible to think about that. So this is the most extensive view for the person who has a boss, and that boss needs to know what happens in that area and not worry at all about the semantics or the technical details. There's no semantics in here. It doesn't talk about artificial intelligence. It just talks about the results. And you can use this as a base for further studies, or you can just use it as it is, and you have the guarantee that in this specific application, the results are compatible with the SIA standard because they've been built using the indication from the SIA technical committee. Now, there is another perspective here for just the tables that we just saw before. There is a perspective for just figures, and you can click on the different parts of the figure and see them change in time. So because they are dynamic, then you can print them in the situation you are in. So if you want to see them at a particular instant of time, you just click on that instant of time and then print. And very importantly, everyone wants to know exactly which data have been used to compute those models. So we give you an extremely detailed perspective on all the data sources. So what you see here is for each data source that has been used in the system, you get a full description, you get the rights of use, you get a link if the source can be downloaded on the web, and that data source is the entire data set, not just the part that was used by the system to build the account that we just saw. And so basically, while the system is computing more information, you can already start looking at things. You can stop the computation if you want, or if you can ask for more things. And to comply with the C account, we don't have everything yet, but we do have extent condition, particularly at the moment is concerned with forest condition, but we can expand it to other kinds of environments. Then there are ecosystem services counts in physical units, so crop provisions in tons, contribution by ecosystems, pollination, sediment regulation in terms of amount of sediment that doesn't get into the water, and monetary for the few things when we have SIA endorsed monetary figures, so we can give crop provisioning, crop pollination, and climate regulation in terms of carbon credit, social cost of carbon for this. This list will extend and will become a lot longer, and we are definitely hoping that this is going to include oceanic and marine variables. Another interesting thing is that we don't have a lot of these, but we are compiling a set of indicators that are SDG or CBD, the biological, the conservation biology indicators, and the more that we get, we put them right here before we have enough to actually compile a specific applications for those indicators, like for example, a specific application for the SDG. So the more, if you want any of these, you can just click them, and basically you get a menu on the left that adds these indicators as potential observations you can make. So you can click on those and keep computing, and they are going to be added to your report just as much as before, and the report will get longer and longer, and basically reflect the same scenarios for all the indicators that you have put together. And these applications can be built in any way. So we can build a specific application for oceans that looks completely different from this, or we can add the ocean accounts to this one, which is something that we are definitely have in mind. You can write your application the way you want, so you can get news tabs, the about page that tells you everything about the genesis and the use of the application. You have a manual, a user guide, etc. So you have seen two of the different ways of using the system. Unfortunately, I wasn't able to show you anything marine, which I played with all day, but then it decided to not work. But the Explorer is the way for somebody who wants the challenge, so they can explore much more freely. But also, you need to know more or less what you want, because you don't have buttons to click. You have to actually ask a question to the machine. It can be exciting, but it may require a little bit of training before you are completely fluent with it. Or you can use an application. At the moment, this one is the top application for our user base, but we can build applications very quickly. This application is about 300 lines of code. So it's very, very easy with the system we have built to create applications that run on the same platform. So they're just a facade, they're just a view of the entire system, but they are easy to build, and they can be built in different languages. We have one in Spanish here. We're building others in other languages. They can be built in Chinese, in whatever you need, and it's very easy to translate them as well, so that different people can use the same application in the way that is most suitable for their needs. Okay, so I think I spoke for enough time, maybe even longer than that. So I should probably give space for questions, or to others if they have any comments. Stefano, I don't know if you have anything specific to say.
No, I'm happy to take any question for the 10 minutes.
Excellent.
If you are able to cover the engine, maybe, Ferdinando, while we take some questions, maybe we can.
Sorry?
If you are able to recover the engine while we take the questions, maybe we are able to show the marine regions.
I'm not sure. At this point, I had enough. I've been enough worried about before that I'm not sure. I'll try, but don't look at my screen.
Okay. Well, thank you very much for the demonstration, Ferdinando. And
Sure.
Audience, just so you know, we have about 8 minutes for questions. So please type them in the questions chat box, which is located in the control panel, and I will read them to our speakers. But before I start doing that, I just want to encourage you to download the slides from today's presentation, and you can find them in the handouts drop-down menu in the control panel as well. So let me start with this first question that came in while you were speaking. It asks, the person says, I'm from Indonesia, the largest archipelagic state. I have attended the previous virtual ARIES launching. I understand it still covers terrestrial ecosystem. What might be the best way to proceed to the ocean account of ARIES? Can we do trial and error with the existing ARIES machine, or, oops, I just lost the question. Or should we contact the ARIES team to work with?
Very good question.
Yeah, very good. And also very difficult. I would not suggest trial and error, because we don't have much. And also we have different releases of the platform, and we use a development release for ourselves, which are more data, but they are less secure and certain and less validated. So we don't distribute that too much. And we have some marine data over there, but we are still analyzing and making sure that everything is proper. But in the public applications, you won't find much because we haven't worked in any marine projects at the moment. So the best way to proceed, I think the most valuable thing for us is to know exactly what people want, because it's typically not very difficult to add something to the system. It's quite easy to work with, and you don't have to add anything for a specific purpose. You put the information there for the machine to find, and that's all you have to do. As long as the information is in good shape, then the machines will find it and connect it. So it's not a huge deal to add some functionalities. But it is very difficult if you don't know what people need, and that is the first thing. in order to know what people need, we need to talk to people. So yes, probably I would contact the team, but that could also happen in the context of the ARIES for SIA, which is a project that keeps going, if it's specifically about accounting. So we can have a conversation that actually includes the UN that are supporting this application, if it's a question that can be solved by adding functionality to this specific application. Or you can talk about any other thing. I've been in talks, for example, with the Korean government quite a bit about marine spatial planning, which is a different kind of issue, maybe related, but it's not necessarily accounting. And we're not doing a project at the moment, but I'm hoping to get to resume that conversation, because it's the kind of thing that you can do very, very well with ARIES, and it would be a different application, because you do different things. You have to paint your scenario, you have to set your priorities, you have to compute your rankings, and those are all things that ARIES can do, but you haven't seen in the ARIES for SIA application, because they are different lens on the same problems. Stefano, feel free to add anything you want.
I mean, we are in this webinar also to start thinking about how to move slowly into the marine oceanic topics. So I mean, this is an occasion for us to start thinking about how to do it properly. Maybe establishing a collaboration, a framework for collaboration.
Excellent, thank you. We do have quite a few more questions. Is there a way to incorporate non-market ecosystem services into the accounting? How do you account for the value of people's culture and norms built on ocean locations?
Yeah, no, that's yours.
Yeah, well, first of all the models there for accounting are firstly biophysical models, and then on the second stage they are monetized for the accounts. So basically we build the accounts in biophysical terms, and then we build the accounts in monetary terms, and the user can choose it. Then, I mean, this question is quite complex, because we are talking about cultural ecosystem services. So we need to have the models to tackle cultural ecosystem services. And as you see here, in this first release, we only have a natural-based recreation that is close to cultural ecosystem services. So the value, let's say the cultural value of people requires definitely something else. And we need to implement new models and knowledge for that, being data and models, and it might be very site specific. So the good thing about ARIES is that we can customize models to any site in the world, so that there's not one model fits all, but every region can take into account its own specificities. And yeah, this is the short answer.
Yeah, it may be worthwhile to spend a minute to describe the kind of the knowledge sharing models that we are trying to support, because this system is really not meant for having a centralized database of knowledge. You don't upload stuff to us. You can, as a participant, have your own node and be in charge of that. And we are very much in favor of like a peer-to-peer distributed model, where people who know something about a particular environment or a particular problem or both can put up their own node with the authoritative knowledge that they need. So like indigenous knowledge, for example, this kind of things, they are very often best managed at the site where the attention and the interest for that knowledge is. And we are definitely supporting that model. We are starting with ARIES for SIA with a distributed database that is managed largely by us. But the idea for that is that every country can put up their own node and be completely in charge of that information, so that including the methodologies, so that everybody can customize the system, not by telling us how to customize it for their needs, but to doing it themselves and changing whenever they like it and whenever they want it. We are completely in favor of a customization that is granular and distributed among the people who care for the results, and not done by us based on discussions and indications.
Excellent, thank you. The next question asks, per Ferdinando, is there a list of semantic keywords and/or definitions that we could download for review?
That's a typical question. We are working a lot on the ontologies, and it's not keywords. It doesn't work like that. It's a very, very complex structure. It's not big. We call the semantics that inspires the system the worldview, just to mention and to recognize the fact that it's a human, it's for humans, and it doesn't have to be unique. You can load a different worldview in the system and use that. The fact is that it's quite partial. The coverage of the worldview at the moment has been basically inspired by what we needed, because we've been mostly the persons who have filled it in. So we are now at a stage where we can start thinking about building it up in a more even and in a more collaborative way, which is the way to go. Also, the worldview is modular, and so you can get the tier 1 spaces that tell you the basic things about things like hydrology, economics, the earth realms, etc. And then you can specialize those with tier 2, tier 3, where you can have a much more detail for disciplinary realms that we are not experts in, but they give you a path to ensure the compatibility of those concepts, because you have to derive them from the tier 1. So it's a complex thing to do. The building the ontology is always the most complex and the most costly thing. It takes a lot of years. So if you want to participate to that is great. What we are going to do now that ARIES for SIA is out and we have quite a bit of applications and a lot of people use our concepts, is to start building a path for a funded path for people to contribute and collaborate into the building of the ontologies. But it's quite technical, it's quite difficult, and there is a lot of people who see what the problem is, and after realizing that it's not keywords, but it's actually concept related by relationships, and those relationships need to be consistent, it's easy to get scared because it's a very difficult process. But it's also the key to everything. And if we have a future, it's because this process goes well. So we're very interested in collaborating.
Excellent. We do have a few questions, but I'm going to only ask one more because we're close to the end of the hour. This
Sure.
last question asks, how does the platform address intellectual property rights in data and algorithms hosted by the platform and derived products created using those data and algorithms?
Right.
And how are data or algorithms that users contribute addressed? Does the user agree to waive copyright or to a specific license? You briefly mentioned license rights to individual data sets, but when multiple data sets are combined to create products, for example, how can users know their rights to use the products, commercial versus non-commercial, etc.?
Right. Yeah, every source, every resource in the system, be it data or model components, has a very long list of fields attached to it, which specify the kind of licensing and whether derived products are available, etc. If you have data that you can use but you cannot share in any way, shape, or form, then you don't get you don't get a map that you can download for those particular data, and you get the information about the credits in the report. If you are in a different situations, things can be different. And plus, you can define specific privileges for usage for data or models or groups thereof, so that if you ask a question to the machine that could be answered by a particular data set, but you don't have an access to that data set, the machine, instead of failing, will find another way to compute it and will just give you the response that you are allowed to see. Now, how those things combine can actually be much more complicated than this, because we do have fields that tell us if we can use derived products, if you cannot use derived products. If you cannot use derived products, then you have to be the owner of the data to use that data, and that's what happens. Basically, it's basically only related to one single user or to one single group of users. Obviously, there is not much incentive to do a lot of work that requires this kind of information, and when just one person can use it. So we are not very much interested in building a set of like ivory towers, given that this system is meant to demolish them. And obviously, you can attach your information to the data, and that information is transparently put in everything that the system produces. You always have the full chain of provenance within the system, so you can track all of these things. it's, I think, the first time that something on this scale is done where you can actually link together and use together a lot of different things that have different licensing problems. So we are at this point able to track everything, but we are not sure of what the consequences of those connections could be, and in a complex model where there are different sources of uncertainty that combine together, in the end is extremely difficult to calculate the uncertainty of the output. In this case, it will be probably very difficult to calculate the licensing of the output when different sources are put together. But at least we have a pathway to just ensure that the specified people get access to the specified resources, and we are obviously as much as possible in favor of using public information whenever possible.
Excellent. Well, thank you so much. Did you want to add something, Stefano?
Yeah, just to say that we are much more in favor of open access and open knowledge. And this is, I mean, the power of integration of data and models is basically this, to make available knowledge that otherwise wouldn't be available. So one thing that we are doing, we say, is to democratize science in a way. So we can think about the Wikipedia example, even though it's not exactly the same, but if you think about data and models and put them together in a Wikipedia way, then is what we are trying to do. So as Ferdinando said, we are able to track and limit access and yeah, do it the usual way, but our vision for the future is to make the best knowledge available to make nature count for global sustainability.
Yeah, we're also hoping that this is an incentive for people to open up their data, because if you add your data to an ecosystem where your data can interact with other data and it can be part of a model change that you hadn't thought about, then your data is more useful, the value is much higher, and you can get credit for the use of those data because it's automatic in the system. So what we're hoping to be building is an incentive for people to open things up, not a way for people to keep their own little tower and just be happy in it. It's very much the opposite of our intention. But it's possible because we know the world is what it is.
Excellent. Well, I just wanted to note that in the spirit of sharing, and I did put your website into the chat box for anyone who wants to go directly to their website and learn a little bit more. Well, that last question does conclude our webinar. I know there were some more questions, but if your question was not addressed today, it will not be ignored. Unanswered questions are going to be sent to our speakers who can respond offline. And I'd like to conclude by thanking our speakers for sharing their research with us, as well as Jeff Wilgus and the PRSSO for sponsoring this event. And as a reminder, the recording for this webinar will be available later today on the NOAA Central Library YouTube channel, so please let any interested colleagues know about it if they could not join us live today. NOAA Central Library is proud to host presentations like today's that feature the work of NOAA community partners. So thank you for joining us, and be well. Have a wonderful afternoon or evening in the case of Ferdinando and Stefano. Thank you.
Thank you.
Thank you.
Thank you.